All right, let's just jump right in. I want you to picture the most dangerous, unpredictable places on Earth. A collapsed building after an earthquake, a raging wildfire. Now, what if you could send in a first responder that can navigate that chaos, learn as it goes, and save lives in places where humans just can't? Well, today we're going to break down how this isn't science fiction anymore.
You know, in any rescue mission, the one thing you can't get back is time. The clock is always ticking against you. But we're seeing a new ally join the fight, one that doesn't get tired, doesn't feel fear, and can operate with just incredible speed.
So why is this new ally so critical right now? Well, because the world itself is becoming a more dangerous, a more unpredictable place. We're seeing disasters that are more frequent, more severe, and frankly, a lot more complex than what we've faced before.
And this number really shows you just how high the stakes are. Data from thousands of rescue missions shows that for people who are trapped, the survival rate can plummet by a staggering 80% in just the first 18 hours. I mean, every single second matters. That window for a successful rescue is terrifyingly small.
And that immense pressure, well, it really highlights the limits of even our best human-only rescue teams. When you're dealing with collapsed structures, zero communication, and constant danger, the need for a new kind of help isn't just a nice idea, it's become absolutely essential.
So, if our human teams are stretched to their absolute limit, what's the answer? Well, we're now seeing the rise of a completely new generation of autonomous rescuers, AI-powered robots built specifically to go where people simply can't.
And let's be really clear about this. We're not talking about the remote-controlled drones you might be thinking of. No, these are true autonomous agents. They can see, think, and react to incredibly high-stakes, chaotic environments all by themselves. So what's their secret? What's the superpower that lets a machine make life-saving decisions in a place it's never, ever seen before? The whole thing comes down to a concept called reinforcement learning. Reinforcement learning, or RL for short, is so cool because it basically mimics how we learn. Seriously, think about how you'd teach a dog to sit. When it sits, you give it a treat. That's a reward. When it doesn't, nothing happens. The dog slowly learns through trial and error to do the thing that gets it the most treats. RL agents do the exact same thing, just millions and millions of times faster. This whole process runs in a constant feedback loop. Let's walk through it. First, the robot perceives its surroundings, using all its sensors. Second, it acts. It makes a move. Third, it gets feedback from the environment. Was that a good move? Here's a reward. A bad move? That's a penalty. And finally, it learns, tweaking its internal strategy to get more rewards next time. It just does this over and over and over, getting a little bit smarter with every single cycle. But here's where it becomes a real game changer. It's one thing to get good at a single specific task, right? Like navigating one simulated earthquake zone. It's a whole other thing to learn how to learn in any new situation. That's the idea behind something called meta-reinforcement learning. So instead of just learning the rules to one game, it's like it learns the fundamental principles of how to play games so it can adapt to a brand new one almost instantly.
Okay, so the theory sounds amazing. But how does this stuff actually perform when there are lives on the line? Let's take a look at the actual results.
You see, this isn't just one single invention. It's a combination of a bunch of key innovations. These robots fuse together data from different sensors, like LiDAR, thermal, and regular cameras, so they can basically see through dust and in total darkness. They run incredibly powerful AI on tiny, low-powered chips, which is crucial for battery life. They have resilient communication systems built in so they don't just stop if the network fails. And maybe most importantly, they're designed to make smart decisions even when they're uncertain and don't have all the info.
And the performance in simulations? It's just wow. It's unbelievable. We're talking 97.2% accuracy in avoiding obstacles, almost 96% accuracy in detecting victims, and over 92% in navigating these complex spaces. These aren't just good numbers. These are numbers that are reliable enough for the real world.
And get this, an average response time of just 3.2 minutes in these simulations. That kind of speed, that kind of efficiency, that's what directly translates into saving more lives, period.
But of course, it's not a completely solved problem. Getting this amazing technology out of the lab and into every single disaster zone around the world, well, that comes with some pretty big challenges.
And this slide right here really spells out why we have to push through those hurdles. On one hand, you have traditional programming. It's rigid, it follows a pre-written script. If it sees something it doesn't expect, it just breaks. But reinforcement learning is the total opposite. It's built for chaos and uncertainty.
In a disaster zone, a rigid script is a death sentence. An adaptive learner is the only way forward.
So what are those big hurdles? Well, there are a few critical ones. There's something called the sim-to-real gap, making sure what works perfectly in a computer simulation holds up in the messy real world. There's safety and verification. How do you guarantee an AI will never make a catastrophic mistake? Then you have practical stuff like limited battery life. And of course, the huge looming ethical questions, like who's actually responsible when an AI makes a critical choice.
But the work being done to solve these really hard problems isn't just for rescue robots. It's actually forging a future where this kind of adaptive AI is going to touch so many parts of our lives.
I mean, think about it. The exact same core principles are what's driving innovation in self-driving cars that have to navigate city streets. We're seeing it in healthcare with robotic surgery and in coordinating entire fleets of robots in warehouses and factories.
And this right here is probably the most important takeaway from all of this. The ultimate goal isn't to replace human rescuers. It's all about creating a powerful partnership. The robots go into the most dangerous spots first, doing the initial search, while the human experts use that real-time information to apply their incredible judgment, their expertise, and their compassion where it matters most. It's human-AI collaboration at its best.
Which leaves us with one final, really big question to think about. As this technology gets better and better, we're going to face some tough new choices. In a life-or-death moment, when you have to choose between sending in a person or sending in an AI, who do you trust? And how do you even begin to make that call? That's something we're all going to have to figure out as this future becomes our reality.